Hello, and welcome to today's problem 53, maximum subarray. So, you're given an integer array nums, and you want to find the subarray with the largest sum and return it. You're given this example of arrays over here, and the output is 6 because the subarray here is the largest one with the sum 6. With this example, the subarray is the largest sum 1 because it's the only value, and with this example, the entire array summed up together is going to be the largest element in the subarray. Okay. And yeah, so the definition of a subarray is it's contiguous, which means there can't be any breaks in it. You can't have like this and this added together. It has to contain everything. So the first solution you would probably think of is a O of n squared one, where the brute force, where you can check for every single element. We can check to see what the sum of all of those ones are. So for this one, so on and so forth, sum them up all together, and at the very end, check what the maximum is and return that. So that solution does work, but it'll struggle with larger arrays because the time complexity is O of n squared. You're going to have to loop through again for every single element. A faster way we can do this is by using something called Kadane's algorithm, which is a linear solution. So Kadane's algorithm relies on the fact that the new maximum subarray is either the current elements or the previous elements, the previous maximum subarray added with the current element. So, right. So like basically, we can rely on this fact to go through the array, check and keep track of what the current sum is so far, and determine whether or not the value is greater with the new element or without it. So if we go ahead and put this over here, we have, let's say we start off with -2, right? We know that the current sum so far is 0, and the max subarray so far at this given moment is as a -2, right? Because we're starting off with this one. Now, with this current sum over here, we can go ahead and move this forward, figure out what the current sum is. We check at first is -2, and will -2 positively or negatively help the maximum subarray? It'll negatively help because -2 will end up like decreasing the maximum sum, right? So we're gonna want to have that set to 0, and we're gonna want to move forward again. We hit 1 this time. Will this positively or negatively help? Well, it'll positively help because it's a positive number. So we'll go ahead and add 1 here, and then we move on to -3 over here. Well, will -3 positively or negatively help? Well, 1 minus 3 is -2, right? So at this point, it's actually negatively helping what the maximum sum will be. So at this point, we'll just want to have this reset over to 0 and basically exclude all of these elements, because since it has to be contiguous, having a positive number 1 here won't help because you have a -3 value over here, which decreases the amount to -2. So it's better to have not included it at all and just include the number 0 over here instead and kind of move forward as you go along. With this value 4 over here, you can see that it's positively helping, so we enter in 4 here as the current maximum sum. Oh, also, the entire time while you're doing this, you want to figure out what the maximum is between the current sum and the current element at maximum sub, and then we'll have that as the current maximum value. So we can have that right now as 4. We check again, see what whether or not it's beneficial to have -1. Well, it's not beneficial, but it's still a positive number, so we'll have that. We'll keep going on with 3. And because it's not beneficial, the maximum sub still stays at 4 because it's the maximum so far. We hit 2, we increment the pointer again, we hit 2, and the current sum ends up equaling 5, right? So it's better to include all of this and have this sum up to 5 and have this become the new maximum. So we can keep doing that. And then we move forward again, we hit 1, and the current sum becomes 6, causing the maximum sum to also be 6 again. If we move the pointer again, we hit -5, the current sum becomes 1 again. So it's hits all of these values. It's better to not include this. Even if you move this forward and you include all of this, it's still like basically not working. Like it'll still be like 5, it'll be less than the maximum sub. So we now know what the maximum subarray is, basically relying on the fact that you can use the previous maximum subarray and the current element together in order to figure out what it is. So we can go ahead and code up a solution for this now. Basically we have the max subarray, which is equal to, let's say, like the first element so far, and the current sum, which is equal to 0. So next thing we want to do is loop through. So for value in nums, we want to check to see whether or not the current value, or like the current sum, is greater than 0. So if current sum greater than, if it's less than 0, what we want it to do is we want to set the current sum equal to 0 to make sure it's not negatively affecting the max sub in any way, like the sum, the sum in any way. Next thing we need to do is increment. So we do cur sum plus equals the current value, and then we can finally check to see what the maximum sub is of max sub, and then the current sum. And then we can go ahead and return the max sub at the very end. So we'll go ahead and run this. And there you go.